All right, ready to dive deep into some green chemistry?
Always.
Today we're looking at cocktail party chemistry, episode 115.
The aerobic oxidation, the art of green transformations.
Now, aerobic oxidation, I have to admit, sounds a little intimidating,
Yeah,
but, this episode is all about how we can use oxygen
which we literally breathe.
to make chemistry more sustainable.
Right, exactly.
So I'm kind of curious,
Yeah.
what makes aerobic oxidation so special in this whole world of green chemistry?
Well, traditional chemistry, it often relies on, these harsh chemicals.
Oh, yeah.
Lots of toxic stuff, creates a lot of waste, hazardous waste.
I'm good.
But aerobic oxidation, it uses oxygen as a cane oxidant, so the whole process is much friendlier to the environment.
So it's like we're taking these chemical reactions and we're basically like breathing new life into them.
Exactly.
That's a great way to put it.
Yeah.
Okay, so how does this actually work?
Okay, so oxygen, it's everywhere, right?
Yeah.
But how do we harness its power, especially for these complex reactions?
Yeah.
Well, scientists have developed these amazing catalysts,
Okay.
often using transition metals. And these catalysts, they can actually control how oxygen reacts.
So it's not just about like throwing oxygen into the mix.
No, no, no.
It's about using these catalysts to like orchestrate a very specific reaction.
Yeah, precisely.
Okay, and
Yeah.
what kind of impact is this having like in the real world?
Oh, a huge impact, especially in like the pharmaceutical industry.
Okay.
Think about artemisinin.
Okay.
That's a powerful anti-malarial drug.
Right.
Traditionally, it was extracted from a plant, a
Mhm.
very slow, very inefficient process.
Yeah.
But now, with aerobic oxidation, scientists have developed this semi-synthetic method to produce artemisinin.
Oh, wow.
Much higher yield,
Okay.
significantly less waste.
So we're not just making these life-saving drugs more sustainable, but we're also making them more efficiently.
Yes, exactly. And that's just one example.
Okay.
Aerobic oxidation. It's being used to produce all sorts of fine chemicals, those
Oh.
building blocks that go into everything from fragrances to pesticides.
So we're really talking about a fundamental shift towards cleaner chemistry across the board.
Yes, absolutely.
It's interesting.
Yeah.
We're always looking to nature for inspiration when it comes to sustainability, right?
Right.
But it sounds like nature has been using aerobic oxidation for like millions of years.
Exactly. I mean, think about how our bodies use oxygen for respiration.
Oh, yeah.
That's a form of aerobic oxidation. And there are countless examples in nature where, enzymes,
Which are basically what? Biological catalysts.
yes, they facilitate these kinds of reactions.
So we're basically learning from nature's playbook, and we're applying those principles to industrial chemistry.
Precisely. And it's really amazing how often we find that nature has already figured out the most efficient solutions.
That's so cool.
Like, take lovastatin, for example.
Okay.
It's a drug that's used to lower cholesterol,
Mm-hmm.
produced by a type of fungus, and aerobic oxidation plays a key role in its biosynthesis.
So a fungus figured this out before we did.
Yeah, pretty much.
That's humbling.
It is.
But it's also really inspiring, right?
Yeah.
So if nature's already so good at this, like, why are we even bothering to create synthetic catalysts? Wouldn't it be easier to just, let nature do its thing?
Well, nature's enzymes, they're incredibly efficient,
Right.
but they're often very specific to like a particular reaction or a particular organism.
Okay.
What we're trying to do is create synthetic catalysts that are more versatile,
Okay.
more robust.
So we can apply these principles to a wider range of applications.
Exactly. It's like we're taking this beautiful melody and we're arranging it for a full orchestra.
I like that.
Yeah, we're building on nature's brilliance to create something even more powerful, even more adaptable.
I'm definitely starting to see why this is more than just like a cool scientific discovery.
Right.
We're talking about a potential paradigm shift in how we approach chemistry, right?
That's exactly right. It's not just about, tweaking a few reactions here and there.
Yeah.
It's about fundamentally rethinking how we do chemistry.
And the implications are, they're huge
Yeah.
for the environment, for the economy, for human health.
Absolutely.
Wow, this is all incredibly fascinating.
Yeah.
And I have a feeling we've only just scratched the surface.
We have. There's so much more to explore in the realm of aerobic oxidation.
Okay.
In the next part, we'll delve deeper into the specific applications of this technology, and we'll see how it's already making a real-world impact. Stay tuned.
Sounds good.
So, it's amazing how something as simple as oxygen can completely change the game in chemistry.
Yeah, in the last part, we were talking about how scientists are basically taking inspiration from nature, right?
Right.
To use oxygen in a whole new way,
Exactly.
creating these super efficient, eco-friendly reactions.
Yeah.
So I'm kind of curious, where are we actually seeing this, like, being put into practice?
Well, one of the most exciting areas is in the pharmaceutical industry.
Oh,
As we touched on earlier, aerobic oxidation is making it possible to produce essential medicines with far less waste
okay.
and much higher efficiency.
That's great.
Yeah, it's pretty cool.
Can you give me a specific example?
Absolutely. Let's look at the production of ibuprofen.
Okay.
You know, that painkiller that's probably in most of our medicine cabinets?
Yeah, definitely.
The traditional way of making ibuprofen involved like a 6-step process,
Oh, wow.
generated a lot of waste.
Uh-huh.
But now, with aerobic oxidation, scientists have been able to streamline that process, reducing it to just 3 steps
Wow.
and significantly cutting down on those byproducts.
So not only is it better for the environment, but it sounds like it's also more cost-effective.
Exactly. And that's one of the key things about aerobic oxidation. It's not just about being green.
Right.
It's about finding smarter, more efficient ways to do chemistry, and that's good for everyone involved,
Absolutely.
from the manufacturers to the consumers.
Okay, so it really sounds like this could revolutionize the chemical industry.
It really could.
But it's not just about medicines, right?
Right.
What other applications are out there?
Well, another area where aerobic oxidation is making a splash is in the production of fragrances and flavors.
Really?
Yeah, you know, those complex aromas and tastes that
Yeah.
make our food and perfumes so appealing.
Mm-hmm.
Many of them are created using fine chemicals, and aerobic oxidation is proving to be a game changer in how we make those.
So, like, the next time I spritz on my favorite perfume, I should be thinking about aerobic oxidation.
You could, one example is the production of vanillin.
Okay.
That's the primary component of vanilla flavoring.
Right.
The traditional way of extracting vanillin from vanilla beans, it was very expensive,
Yeah.
very limited.
Okay.
But now, thanks to aerobic oxidation, we can create vanillin from lignin.
And lignin is...
It's a byproduct of the paper industry.
Wait, so we can make vanilla flavoring from paper waste?
Pretty much.
That's incredible.
It is.
So not only are we finding greener ways to create these chemicals, but we're also finding ways to utilize waste products that would otherwise just end up in landfills.
Exactly. It's all about closing the loop
Right.
and creating a more circular economy.
Mhm.
And aerobic oxidation is a key tool in that process.
It sounds like aerobic oxidation is kind of a superhero in disguise.
Yeah.
You know, quietly working behind the scenes, making our world cleaner, more
Yeah.
efficient,
Mm.
more
I
sustainable.
like that analogy.
Yeah.
And this isn't just some futuristic concept.
Right.
These applications are happening right now,
Okay.
and they're only going to become more widespread in the coming years.
Yeah, that's what I find so exciting about this.
Mhm.
It's not just theoretical, it's actually making a difference
Yeah,
in the world today.
it really is.
But I'm also curious about, the challenges.
Yeah. What are you thinking?
Well, if aerobic oxidation is so great, why isn't it being used for, like, everything?
That's a good question. There are a few hurdles to overcome.
Okay.
One of the main ones is finding the right catalysts.
Yeah, we talked about those
Yeah,
earlier.
Those that are...
Those are like the key to making this whole thing work.
Exactly. They're what make it possible to control how oxygen reacts and create those specific chemical transformations we need.
Okay.
And finding catalysts that are both efficient and selective for a particular reaction. It can be tricky.
So it's like trying to find the perfect key for a very complex lock.
Precisely. And the search for better catalysts is a big part of the ongoing research in this field.
I can imagine.
Yeah, it's very important. But here's where things get even more interesting.
Okay.
Sometimes, instead of trying to mimic nature, we can actually use nature's own catalysts,
Oh, okay.
like enzymes, for these industrial processes.
So we can actually harness the power of those biological catalysts we were talking about earlier.
Exactly. There's a whole field called biocatalysis, where scientists are exploring ways to use enzymes to facilitate chemical reactions in a more sustainable way.
Okay.
And aerobic oxidation is playing a big role in that.
That sounds incredibly promising.
It is, but of course there are challenges with that too.
Yeah, like what?
Well, enzymes, they're often very sensitive.
That's
They
fine.
need very specific conditions to function properly.
Yeah.
They might be sensitive to temperature, pH,
Okay.
or even the presence of certain chemicals.
So finding ways to make them more robust and more adaptable for industrial applications is a challenge.
It's a big challenge.
Yeah, it sounds like there's a lot of fine-tuning involved.
There is, but the potential payoffs are huge.
Yeah.
If we can successfully integrate these biocatalysts into industrial processes,
Right.
we can achieve even greater levels of sustainability and efficiency.
I'm sensing a theme here.
Yeah.
It seems like a lot of the challenges with aerobic oxidation come down to finding the right tools for the job,
Exactly.
whether it's a synthetic catalyst or a natural enzyme.
That's a great observation. It really highlights the importance of ongoing research development in this field.
Yeah.
As scientists continue to explore new catalysts and optimize reaction conditions,
Right.
the applications of aerobic oxidation are only going to expand.
This is all incredibly exciting.
It is.
But, before we get too carried away with the potential of aerobic oxidation, I'd like to kind of take a step back
Okay.
and consider the bigger picture.
Sure.
We've been talking a lot about green chemistry, sustainability,
Right.
but what does that actually mean in the context of, the chemical industry as a whole?
It's a great question. It's not just about using, less harmful chemicals
Yeah.
or reducing waste. It's about designing chemical processes that are just inherently safer,
Okay.
more efficient, more environmentally friendly throughout their entire life cycle.
So it's not just about like tweaking a few things here and there.
No.
It's about a fundamental shift in
Yeah.
how we think about chemistry.
Exactly. And that shift, it's being driven by this growing awareness of the impact that our actions have on the planet.
Right.
We're realizing that we can't just keep doing things the way we've always done them.
Yeah.
We need to find new ways to meet our needs
Mm-hmm.
without, compromising the health of our planet.
And it sounds like aerobic oxidation is playing a key role in that transition.
It really is. It's one of many tools in the green chemistry toolbox,
Yeah.
but it's a powerful one. By harnessing the power of oxygen, we're opening up a whole new world of possibilities
Yeah.
for creating a more sustainable future.
This has been a really enlightening conversation.
It has.
I'm feeling a lot more optimistic about the future of chemistry.
That's great to hear.
But before we wrap up this part, I'm curious about something else we mentioned earlier. Biomimicry,
Oh, yeah, good one.
taking inspiration from nature.
Right.
What are some other examples of how nature is inspiring innovation in the chemical industry?
Oh, there's so many fascinating examples. I mean, nature has had like billions of years to perfect its design.
Yeah, that's true.
So it's this treasure trove of inspiration for engineers and scientists.
Okay.
Take, for example, the lotus leaf.
Okay.
Have you ever noticed how water just beads up and rolls right off of it?
Yeah. It always looks so clean, even after a rainstorm.
Exactly. And that's because the lotus leaf has a very unique surface structure.
Okay.
It's incredibly water repellent.
Yeah.
And scientists, they've studied this structure
Okay.
and have been able to create synthetic materials
Oh, cool.
that mimic this lotus effect.
And those are being used for?
These materials are now being used to create everything from self-creating fabrics to water-resistant coatings for buildings.
Wow, that's really cool.
It is, right.
So we're not just talking about like mimicking chemical processes,
No.
but also like mimicking the actual physical structures found in nature.
That's right. And it goes even further than that. We can also learn from nature's systems and processes.
Okay.
For example, termite mounds have inspired the design of passive cooling systems for buildings.
Oh, wow.
And the way that schools of fish move together, that has informed the development of more efficient underwater vehicles.
It's amazing to think that we can find solutions to some of our most challenging problems
I know, right?
by just observing the natural world.
It really is.
Nature is the ultimate innovator.
Absolutely.
And we're only just beginning to tap into its vast potential.
Exactly.
This is a good place to pause our deep dive for now. We've covered a lot of ground, from those specific applications of aerobic oxidation to the broader concepts of green chemistry and biomimicry.
Indeed. In the next part, we'll explore some of the cutting-edge research in these fields and discuss the exciting possibilities that lie ahead for a more sustainable future. Stay tuned.
So we're back, and we've been talking about this really cool world of green chemistry,
Yeah.
specifically aerobic oxidation,
Mm-hmm.
and how it's changing how we make all sorts of products.
It really is changing things up.
In the last part, we even talked about how nature itself is inspiring some of these innovations,
Right.
like with that self-cleaning lotus leaf effect.
Oh, yeah, that was a good one.
It's amazing how,
Yeah.
nature just figured that out,
Nature's been doing its thing for a long time.
and we're just now catching up.
Exactly. It's a great source of inspiration.
So what other, cutting-edge stuff is happening in this field?
Oh, so much exciting stuff.
Yeah.
One area that's really promising is the use of artificial intelligence in catalyst design.
Okay, so, how is AI involved in this?
Well, remember how we talked about finding the right catalyst being like a huge challenge?
Yeah, it sounded pretty tough.
It can be, but now scientists are using AI algorithms
Okay.
to analyze like massive amounts of data
Okay.
and predict which catalysts will be most effective for specific reactions.
So AI is speeding up the discovery process.
Big time. And it's leading to the development of even more efficient and selective catalysts for aerobic oxidation.
That's really cool. What else? What else is out there?
Another area that's really heating up is the development of flow chemistry techniques for aerobic oxidation.
Okay, I'm not familiar with flow chemistry.
So traditionally, like chemical reactions are carried out in batches.
Okay.
But with flow chemistry, the reactants are continuously pumped through a reactor, making the process more efficient
Oh,
and much more controllable.
interesting. So it's kind of like instead of, I don't know, baking a cake,
Yeah,
we're making like a chemical smoothie.
I like that. Yet it's a continuous flow.
Okay, so this continuous flow approach, it's particularly well suited for aerobic oxidation.
It is, because it gives you really precise control over the amount of oxygen being introduced
Okay, and that's important for.
for safety and efficiency.
So it sounds like we're moving towards a much more streamlined and automated approach to chemistry.
Are, and that's not only good for efficiency, but it also reduces the potential for, human error,
Right.
makes the whole process safer.
Yeah, that makes sense.
Plus, flow chemistry systems, they can often be scaled up more easily,
Okay.
which is really important for those industrial applications.
Right. Okay, so we've got AI helping us design better catalysts,
Right.
flow chemistry making the whole process smoother, safer.
Mm-hmm.
What other innovations are out there in the world of green chemistry?
Well, there's a growing trend towards using renewable feedstocks for chemical production.
Okay, can you elaborate on that a little bit?
Yeah, so traditionally, a lot of chemicals have been derived from, fossil fuels,
Right.
which are finite and they contribute to climate change.
Yeah, not good.
So now scientists are exploring ways to use biomass,
Like,
like agricultural waste or algae, as starting materials for chemical synthesis.
so instead of digging up fossil fuels, we're like growing our chemicals.
That's the idea. And this is where aerobic oxidation is really useful,
Okay.
because it can be used to selectively convert biomass into valuable chemicals.
Oh, that's cool.
Yeah, so for example, researchers have developed methods to use aerobic oxidation to transform lignin.
Which is, remind me.
It's a byproduct of the paper industry into
Okay.
vanillin and other useful compounds.
So again, we're finding ways to utilize these waste products and turn them into something valuable.
Exactly. And it all comes back to this idea of a circular economy,
Right.
where we're minimizing waste and reusing resources as much as possible.
So, we've been talking a lot about the technical side of things,
Mhm.
but I'm also curious about the human element.
Okay.
Are scientists the only ones pushing for this shift towards green chemistry? Or are consumers playing a role too?
That's a good question. And, it really is a collective effort. Consumers are becoming more aware of the environmental impact of the products they buy.
Yeah, definitely.
And they're demanding more sustainable options.
Right.
And this is putting pressure on companies to adopt greener practices and develop products that are both, high performing
Right.
and environmentally friendly.
So it's like a combination of scientific innovation and consumer demand that's moving the industry forward.
Exactly. It's like a positive feedback loop.
Yeah.
Consumers demand more sustainable products. Companies invest more in research,
Mm-hmm.
which leads to more innovation.
Right.
And as those innovations become more widely available, it further encourages consumer demand.
Yeah, absolutely. This whole conversation has been so inspiring.
Yeah.
I'm walking away with like a whole new appreciation for the power of chemistry to create positive change.
That's great to hear. It's easy to get caught up in all the negative stuff.
Yeah.
But it's important to remember that there are people out there
Right?
working on solutions.
Yeah.
And chemistry, especially green chemistry, is at the forefront of that effort.
Well said. We've covered a lot of ground in this deep dive.
We have.
From the tiny details of aerobic oxidation to, like, the big trends shaping the future of chemistry.
Mm-hmm.
But if there's one takeaway I want our listeners to remember,
Yeah.
it's that there's reason to be optimistic.
I agree. The challenges are real, but so is our capacity for innovation and collaboration.
Yeah.
And by embracing the principles of green chemistry
Right.
and drawing inspiration from nature,
Right.
we can create a future that's both prosperous and sustainable.
Couldn't have said it better myself. Thanks so much for joining me for this deep dive.
It was my pleasure.
It's been really, really enlightening. And to our listeners, stay curious, stay informed, and keep asking questions. Until next time, I stay ACA.